All right. I'm sharing. All right. Uh, could anyone confirm if they can see my screen and can you see the GitHub page?
Yes, please.
Yes, please. All right. Thank you. So, oh, okay, we have a small issue here. So I'm going to have to hold on. Yeah, should be it. Yeah. No, so basically, um, I think first of all, for those of you who may be joining one of our sessions for the first time, welcome. We are glad to have you here. There are a few people on the call who are already, kind of known faces, and they are very active contributors to the community. So yeah, we welcome you all, and maybe just to start us off, let me open the floor for someone who um, is kind of not, who has never been to one of our meetings to just say hi and tell us maybe what they are working on or what they do. That would be nice. If one or two people who are joining for the first time.
Yeah, hello. Um, my name is Alidu Abubakari. I'm currently a PhD candidate at the University of Milano, and I'm Bikoka, and I'm working on software generation with LLMs here.
Awesome. Thank you. We are in the same country code, so yeah, good to be connected. Yes. Anyone else? All right. If it's only Alidu, then I guess we can go ahead and start. Yeah. So as I was saying earlier, I think this was I think at the beginning of this year, someone asked me, what do we want to do as a community? And there was a lot of things that came to my mind because there's always, so much to do, especially nowadays with the way things are moving very fast in AI. But for us, the limitations are always about data. Okay, so when it comes to what we can do and what we cannot do, it's always about data. Now, really kind of not have this data limitation. I think of text to speech. At the same time, this is also one area that really add value to the communities that we are trying to include in the digital, evolution, because there are things like machine translation, which is great, if we want to think about training content, translating content, if we want to think about training LLMs, which still have a lot of exponential effects and benefits. If you think about like what Alido is doing in software generation, that kind of thing, we didn't need text for that, and it's important. However, when you are thinking of the user, the end user, and you're thinking of someone in some rural area of Ghana, and you want to think about what would be their first point of contact with artificial. I think speech is really not built your first LLM, you may not have built your first machine translation model. You may not have built your first ASR model, which is more of a speech to text model. But I think if you try to invest your time in building text to speech models, not only would you be able to kind of overcome the challenge of data because it has a good amount of data available, you could also really build something that could be useful, right? Think about accessibility. People with visual impairments, and all sorts of other reasons. Even people without visual impairments benefit a lot from these text-speech models. I happen to be living in Italy at the moment, and it's interesting. Like wherever you go, whether you're in the bus, whether you're in the train, there in the elevator, there's always a text-speech model somewhere, right? Like there's always announcements, which is not necessarily human doing it. There's a model behind it, and that's the whole text somewhere. And considering our languages are spoken languages, this is very important because if you present it on a paper to someone in the rural area, they may not be able to read it. They may not have the time to read it. But if you deploy a model, a text-to-speech model, and you are able to feed the text into that and broadcast it through the model, you could actually reach people, right? So I think it's really something that we could focus on. We could do a lot. And now let's come to the caveats. Let's come to the realities. Okay, so the TTS system we are going to kind of practice with today is Piper TTS. Some of you may have already heard about it. Let me just scroll to the repo. I like to always kind of give credit to the people who just build stuff and make it available to all of us to use for free. And when I think about that, it makes me also think about doing something that somebody else also benefits from, right? So this is Piper. It's one of the, I think, early neural text-to-speech models that came as a system. The conditional model and these systems produced very robotic voices. There's even one called eSpeak also. And those ones, they are very lightweight, very fast. They don't need GPU, very fast. But their challenge was that they were very, very robotic, and people could not really kind of benefit from the voices very well. You just had got the information, but there was no human engagement there. And then Piper came along. Piper was one of the first kind of models that really took us from those foundational, models, systems that were very robotic to something which was a bit more human. But the benefit of Piper is that it's built on existing systems. Because you can see here, references we speak of minimization. And text speech systems that is around up until now. So I know that there is always a lot of announcements about the LLM based text to speech models, and they really sound great. And I'm not going to tell you that Piper is trying to compete with those ones when it comes to the clarity of the sound or the expressiveness, and I think there's room for that. we definitely need to also focus on the LLM text speech aspect, and maybe we will do sessions on that as well. But when you use something like Piper, you are using it because you want the benefit of something that sounds good and can be used, and also you want the benefit of something that is practical for our environment. Because when you train a Piper model, you know that at least you can deploy it even a basic CPU enabled device. The Piper runs on Raspberry Pi. There are implementations of it for mobile as well. And so I think the whole idea behind it is to make it fast, and it's still benchmarked as one of the fastest TTS models around. And what I particularly like about Piper is the size of the model. So like you train a model and your model size is like 68 megabytes. That's great, compared to some of the 5 gigabyte and 10 gigabyte models that you're looking at. You want to go with there and base text to speech. So I think I wanted to give that introduction so that you understand the system you're working with. And yeah, so we can dive into some of the other aspects as well. So now that that is out of the way, let's now look at the data set aspect, okay? Hold on for me, let me okay, I think everybody is admitted on the call. All right, so let's keep going. Okay, I've got one this. Aloysius. All right, yeah, so let me go back to the data set part. Yeah, so now I've put together this repository on our Ghanaian NLP GitHub to basically like document it and make it easier for you to follow. Okay, so our whole goal, what we call Ghana TTS, is to make it like easy to train Piper TTS models. And what we are going to do is we are going to provide data sets that you can use. And we also provide this notebook, which we are going to go through today. And we will even also provide the models that we fine-tuned. So as you can see here, I've listed one model which I fine-tuned. And this could be used as a starting point if you want to maybe train a model for tree or similar languages like tree. But if you are not in fine-tuning and you have to start from scratch, I think Piper is really good, and even if you start from scratch, you can get some very good results. So, but essentially, we want to make it as easy as possible. And I have created a collection here on our Hugging Face. Let me open that. So if you come on Hugging Face, we do have an account there. There's Ghanaian NLP and there's Ghanaian NLP community. So the Ghanaian NLP community is what you are looking for. Okay, so you look for Ghanaian NLP community. There is the Ghana TTS collection. So let's just go to the Ghana community homepage. So you see it easily. So there you go. Under Ghana TTS, you click this. For now, you just see 3 data sets. I'm going to put some more data sets out there. And it's important for you to look at this because you will need it when we come to the notebook, right? So based on the data sets you want to train with, you are going to need to copy the ID. So, the Hugging Face data sets, the IDs are essentially the user / the data set name. So like if I copy this data set, the ID becomes, let me just open a text file and paste it. Control V. So you see, if you can see what's in my text file. Ghanaian NLP community / the same name as you see here. And that is essentially how you're going to tell the notebook that I want to train with this data set, or I want to train with that data set. On the other hand, if you want to put together your own data set, that is fine. Don't wait for me, don't wait for us to put data sets out there. You can actually work on your own data sets. We have provided the tools for that. There is a repository here that you can use. I thought I had to actually reference it here. Let me see. Yeah, so here you see how to prepare your data set and push to HF here, right? That's if you want to prepare your data set and use it. All you need to do is to go to this yeah, it's called TTS data preparation, right? Now this repository, it has several scripts that you need to run. And when you are done running all these scripts, your your end data set is going to look like what we were just looking at. So when you are done preparing your data sets using those scripts, you are going to end up with something that looks like this, published on Hugging Face. Audio, text aligned. Now, some small things are important, very simple things are important. All the headings, the labels you have for the various columns, very important. And also the format. So there are different ways you can push the same data to Hugging Face, and it may make it accessible or not accessible when you need to train. So I think if you look at that repository, we do include a code there for actually pushing it to HF where you end up with something like this. Okay. And then you can have your own data sets, you copy the ID, and you can use that for the training. Yeah, so if you want to do that, if you have any questions, feel free to let me know. There is a video of the session we did on that. So I'll recommend that you watch the video because not everything is in the code, right? So you watch that video and you learn how to make your own data set. But yeah, if you're working with tree, then you have some data sets already that you can use as an experiment. All right. So with that out of the way, I think we can begin and we can experiment with this notebook. But first of all, let me make it clear in terms of where you find this link to this notebook. I don't think it's big enough, but it's here. Probably it's kind of difficult to find, right? But the train or fine-tune a Piper TTS model, you click open in Colab, watch tutorial. I'm going to upload this recording here so it becomes accessible. So open in Colab, you click on this and you get to the notebook. So let's do that. Okay, I'm going to kind of disconnect the previous notebook I ran before this session so we can all start from scratch. All right. So this is the notebook we have just opened. It is a public notebook which opens in Colab. I recommend training in Colab, but for those of you who have MacBooks, you probably already have GPUs, and so maybe you're comfortable training with your Mac if you want. But Colab from Google, it does offer free GPU. You do get like 4 hours of access to the T4, the Tesla 4 GPU. This GPU has like 16 gigabytes of what do they call it? Of VRAM, and then also 12 gigabytes of the CPU RAM. So it can help you to actually train something and like proof of concept to show that this actually works. And then if you need to be and you can buy credits like how much you like you pay $10, $10 and you get like 100 credits. That is equivalent to like 100 hours of training, you know, on a T4 GPU. So if you try this with a free, you can easily upgrade for just $10, and you can actually train a model that can actually sound and say stuff with about just 20 bits. So that'd be like what people, you know, you can do that with Piper. Yeah, so yeah, that is essentially how it works. So yeah, for me, I have access to additional GPUs, but for this exercise, I'm using the T4 so that if you want to also start from the free, you can also do that with this video. And I connect. There we go. We are connected to the T4. You can see down here T4 by 3. And then the first thing is we need to authenticate our Hugging Face. Okay, so Ghanaian NLP data sets, for you to access them, you are going to need to be authenticated on Hugging Face. We do that because we also want to kind of bring everybody under the same umbrella. So you authenticate, you get free access to all the data sets. So if you don't have an account on Hugging Face, please create an account. And then when you run this cell, the first cell, let's run. Yeah, so you see, you're going to get this output here. It's going to ask you to authenticate your Hugging Face. Click on this link here, your Hugging Face tokens page. Now, it will bring you to this page. If you should have an account before you do this, so you can just click on one of these. If you want, you can create a new token. But if this is the first time, you'll probably not have anything here. So you create a new token. So let's just use that so that for the first time. So token name, you can name it anything. You can say GTTS. I would say for the token type, sometimes it's tricky when I use the fine grained, so I like to go for the classic. Yeah, read, write. Yeah, I'm going to go for write. So switch from the fine grained. Okay, we go with the fine grained. You have to select one pension. You can creating a broad access token. Okay, so you want to take good care of it. But if you don't have like some treasured assets on your Hugging Face, it's not like someone's going to use it to delete your stuff. So you're fine. So right, you switched to that, create token, and there you go. So you have your token. You copy that. Let's come back to the notebook. You paste it here where it says token, and then you can leave this text, say login. So there you go, you're authenticated. So now when you get to the point where you need to load the data set, you are going to be able to access the data set without any issues. There's also a cell here for mounting your Google Drive. So in Colab allows you to mount your Google Drive while doing your work in Colab, so that if you wanted to say save your stuff in Drive directly. You can do that. This is useful, especially when you don't do your daily work. Take this one for say 3 hours, or even for if you are using the free version and you have a maximum of about 4 hours, 3 hours 45 minutes to use the free version. So if you are training and you are not like sitting there watching it, I even so that stuff doesn't get lost, right? So the way I've set up this notebook is set up for storing the stuff in Google Drive. And so you click on this, connect to Google Drive. Continue. It will ask you for all these permissions you can grant it. If you do not want to use the Google Drive, I mean, if you're using your Mac, whatever, you can skip this. If you're running this in your own Jupyter notebook, you can skip this. Yeah, but now we are done with the preliminary stuff. Now we need to install Piper, the actual system we are going to use for the training. So yeah, it kind of outputs a very long code. So I have put this command up, this magic command here, or bash to just capture the output so we don't see that wall of text. But essentially, it's going to install Piper and it's going to install all the other requirements. It's also going to create some directories that we need for the training. Okay. Sorry, I'm not looking on the Google Meet screen, so I may not see chats as I'm kind of on this page. Yeah. So yeah, this one takes a little bit, but I think one of the key lessons, this notebook took me a while, guys, like it wasn't straightforward because Piper, like I said, is now a bit old. So you need to kind of, it's like, you know, when we used to make all these things from cans, from tins, you would need to kind of, you know, fit it a little bit and make it work. Yeah. So this was the solution that worked for me. So for example, we are using this GitHub repository. Okay. If you search for Piper or you are using these AI systems to generate code, which is what we all do now, they may point you to another Piper repository. That one is just Piper. It doesn't have the Piper 1/GPL. That one is outdated. So if you use the Piper GitHub one, the one that is not from OH Voice, which is just github.com/raspi/Piper, it's an old outdated model. So if you try to use that, you want to, so there's not that capture yet. This name and that works. So that's what we are using. And then now we are done. We've installed Piper. We've created directories. Now we are going to go to the next step of actually downloading and prepping the dataset for training, you know, just by running this code. Okay. So let me explain what you are seeing here, especially the main things you need to adjust. You do have here the dataset ID, which I talked about earlier. Here I do have this dataset, which I recently uploaded to our community page. It's a key female speech dataset, and it's actually a dataset that was produced by Farmerline. I don't know if some of you know this organization. They work with farmers, and they put it out there for open access. So kudos to them. And essentially, that is what I have here in my demo. But we can change it just to show you how it works if you want to go and copy your own ID. You can use any data set, but yeah. So look, this is one of the data sets that we actually have here in the Ghana TTS collection. The key trigram speech text power. Okay, so it's a Bible data set. It has the Bible text aligned with audio, and uh, it's also split into trigrams. So trigrams meaning it's not the long sentences you have. You have the sentences split into three-word sequences. That was an experiment I did, and it seemed to help the training to move very fast. So if you go to the collection, you are going to have this data set there, and you're going to have the original data set, which is the full sentences with their audio. And that one is also there. So for me, when I was training, in fact, the didn't get is actually so experimenting with it and finding out how it works. But it does struggle when you now want to, you know, number one, inference on very long text. And also it does have some pauses and stuff. But anyway, just for proof of concept, you can use this. And the split, you can leave it at train. Yeah, it's usually referring to this train. And we are going to slip the data into train and test when we get to the training code. But at this stage, you just pull the train split. Most data sets have just one split anyway. So yeah, we use that. And then here you have the max samples. Okay, so here you define how many maximum samples you want to pull from the data set. If you look at this data set here for the trigrams, you see here under train split, it has 166,000 rows. And that's quite a bit. So if you wanted to a group of you spend a lot of time waiting for all that data to download. On top of that, you will not have enough space in the Google Colab to store all that because TTS data can be very heavy. You see here it's like 12.2 gigabytes, but when you prepare it, when you download it and you minimize it, you cut it up and stuff, it becomes very huge. So yeah, except like you have finished all the experiments and you are ready to train state-of-the-art TTS for all of us to use, then you don't necessarily need to download everything. For this experiment, I'm going to pick just 1,000 samples. Just 1,000 samples. Now you see how we do it here. Don't try to be smarter and go and remove the underscore, please. You keep it like this, and then the zeros are after the underscore, right? So if you wanted to do 100,000, this 100,000. If you switch this to comma, you are going to run into errors. So we keep that 1,000. Yeah. If you want to find the zeros here, the speaker ID, you leave that to none. Piper allows you to train multi-speaker TTS. We can do this in another session where we try that. I have actually not yet trained a multi-speaker TTS because we don't have enough data. Most of our data is just a few. So even though you may have different speakers, sometimes you end up with about 4 or 5 speakers for one Bible data set. We tend to use them all together. Okay, and you use all of them because you don't have enough data to try to split them and train separate speakers for each of them. And since in most cases they tend to be the same gender, like unfortunately, most of our Bible TTS is male, so it's very difficult to come along female voices. But if it's all male voices, then no big deal. When you train, the system can normalize it, and you still end up with a kind of generic voice from all the different voice samples that are in your data set. So at this point, we are leaving the speaker ID at none, and then leave this alone. I'll say the minimum and max duration. What I would say about the maximum is that I tried different approaches, and when they went beyond this, so I have audio that goes beyond 15 seconds. So you want to keep this max duration. What it does is take that data set from wherever source you are feeding it, and it filters it to only those that have this max duration. So it gives us that meet this criteria. The minimum duration to is important because if you use anymore, most of the time we have will have a few that are very short sequences. Okay, so some of them may be like 1 second long, or you may even end up with some that are like in the 0 point something long. So those ones could also trip the model, the training when you get to the training part. So we set also the minimum to 3 seconds. You can set it to 5 seconds if you want. But yes, yeah, that's all about that. And then first, make sure you are checking everything right. Because if you run into errors down there, it will be because you didn't do everything right at the stage. So now that we've done that, let's run the code and get our data set prepared. Yeah, so yeah, with this one, we are not hiding the output, so you can see what's going on. It's basically downloading the data set to give you some feedback on what's happening in the background. Oh, wait, did I capture the results? Okay, it takes a little while, so this is the iteration. And so, like I said, if imagine if you have like 100,000, if you were downloading all the samples from the data set, you would need to have more time. So, you just pick. I think for T4 GPU, you can pick probably 3,000. See if you can pick 5,000 samples, and just for the experiment, so flip them down in 5 minutes, 10 minutes, and you can go on with the training. Yeah. Yeah, so yeah, while it does that, let me just see if I can explain a little bit of what's happening. So it's downloading all that data, and it's creating for you a metadata CSV file and a folder. So all the data from Hugging Face is going to be downloaded into a folder on your in this case on your Google Colab. Yeah, that data will not go into Google Drive. The way I've set it up, that data will stay here because it's more like a temporary data. What gets saved in your drive will be the model, the actual model, and the checkpoints from training. So yeah, it's going to download that. The metadata essentially is going to be if you come to the assets, I think we have them. Okay, that's not yet downloaded the metadata, but it's still in the process of downloading the waves. But essentially the metadata is for Piper, it needs a certain structure for the metadata for training. And so it needs it to be type separated. Pipe is the and Piper needs CSVs that are delimited with pipes, and they should have the path to the audio, the text that the audio has, that's the transcription, and then also the speaker ID. This is a standard data set format for training text speech models they call LJ speech format. So Piper has this requirement. So you have this code which does that for you, and then you can do the training. I don't know, maybe 1,000 was too much. Should have just picked 200 so we don't run out of it. Let me see. Okay. I'm going to stop it and I'm going to do 200 so we can move faster. Yeah. So while that goes on, let me just go down to the other cells we'll run after this is done. So yeah, now when you're training, you have kind of two options. Okay, when you're running the training code, you could be training from scratch, which I think is the most likely scenario if you are training your model for the first time, or you could be fine-tuning on an existing checkpoint. So that means that maybe you are using your MacBook, or maybe you are using the colab free GPU. You have run a first training for the 3 hours, and you have all your checkpoints saved. You can resume training from the existing checkpoints, and so you don't have to start from scratch, right? So that you can keep training until you get the results you want. And so for that, I had to put together this patch here. So you see this code here that says apply PyTorch patch. You only need this code. You only need to, it's a long code, so I've hidden it. But you only need to run this cell if you are going to fine tune from the checkpoint. Okay. If I'm continuing from an existing checkpoint, you don't need this. So for this particular session, we are doing more from scratch. So I'm going to run this cell. It goes straight to the training cell. Now, when you are running this cell, if you are training from scratch, this last line here, which points to a checkpoint path, it has to be commented out. Okay, so for me, you see this line here, not commented out because I was fine tuning from a checkpoint. But if you are doing from scratch, you want to uncomment that line. Comment that out by just putting a, what do they call this symbol? Asterisk. No, it's not asterisk, hash. I forgot. You just put that in front of it so you can just comment it out so that you train from scratch. And let me explain also something very important to you. I think one of the reasons why you do not see a lot of Piper models around is one fundamental challenge. I told you earlier that Piper is based on earlier text-speech technologies. One of them is called eSpeak. Now, Piper is she the way we phonemize it are the various sounds in there. So you have co and you have fi, right? Now you need this is about training the language side. If you stop tell the system, the Piper system, how to handle every language. So that if it sees KOFI, it knows that for this particular language, I am looking at the sound ko and so that languages. In fact, if you go to the eSpeak GitHub repository, which this Piper pulls from for training, you're going to find that there are only 2 African languages which have rules in the eSpeak phonemes rules and stuff. It's just Sesotho, it's a Southern African language, and also Swahili. And even those ones, the rules are not like complete. It's not very well done. And so, yeah, if you're here, you're a language expert, you're looking for a project, that could be something you do. But what you now notice here is I have to use a language that is at least close to our language. So what I have to do is to pick a language which is similar. This one is elephant. It is the full meaning of elephant is lingua franca. So it was kind of they call it an artificial language that was developed to help kind of capture different languages together. Okay, so it was developed by linguists to kind of think of it as if Ghana decided we wanted to develop one language that unites all our languages. So we will pick alphabets from all of them and just develop an artificial language. So that is elephant. It was developed for some multiple languages of indigenous people in the Amazon and other places. So one thing I had to do was to test all sorts of languages in eSpeak. And I found that when I used elephant with our languages, it really captured the sounds well. And if you want to do an experiment on that, you want more, you can reach out to me. But elephant was basically one of the languages that really worked well, so I use that. If you use it, if maybe you train with your language and the results are not good, it is coming from here, okay? So if your language is very different from tree, you want to experiment with eSpeak to find what works for you, you can reach out to me. I'll show you how to try it out. But feel free to use the name. Important as a name to the voice. Especially if you are training multiple speakers, this is useful. But for single speakers, still you have to define a name for your voice. So here I've defined Ako as the name. All right. So now you see our data prep is done, right? Look at that. Loaded 200 samples. Metadata saved. It gives us some lines. Now we come here. Sample rates also, yeah, very important, but it's all handled by the data prep, so I'm not even going to that. So let's just run this cell. I'm going to remove this capture command so you can see what is coming out. I'm also going to reduce the batch size because 28 is for if you're using an L4 GPU. L4 GPU has about 20 gigabytes of VRAM. We are using T4, which has 16. So what's the math? Let's just use this. If you have performance GPU, you can increase it. So yeah, and also max epochs. And it's like 3,100. To get a good text-to-speech model, you have to get to thousands of epochs, okay? But don't worry. when you're using something like Piper, you get one epoch in like 5 minutes or so. So you can amass a lot of epochs. Okay. So epochs is like when the model has seen all the training data. So yeah, it depends also on your data size. If your data size is huge, it takes longer to get one epoch. So yeah, that's how it works. So now I think I've said it. Let's run and see how it goes. Oh, I think the capture command is still interfering. Going to run it. So still happening. Okay. Yeah. So yeah, you are going to see a couple of things that looks like errors. They are more like warnings. Okay, so don't worry about them. Like I said, Piper is like playing with your tin can and making something out of them. It's an old guy, but it can do a lot of good stuff. So what you want to see, the good news you want to see is when you see this info, Piper train this dataset processing or transit. When you see that, you're in good shape. So at least that started kind of cutting up your data into those frames we were talking about, and that started doing the training. These warnings are going to be all over the place. It's just warnings. And because these libraries, they are moving on and Piper is still what it is. So we just hope it continues to kind of keep working. Yeah, but yeah, essentially, you see here, it's giving you the feedback on the epochs. So it has done 1 out of 2, 2 out of 2, you know, just like that. And then it will give us, very soon we'll get to 3. Yeah. So I'm going to put this thing back, the capture command. Yeah. So when you run it, it's clean. But actually, maybe I'm going to leave the capture out because without that, you just don't see anything. You don't see what is happening. You don't see if your epochs are down. So yeah, there you go. Oh my God. Yeah. So yeah, yeah, progressing well. Let's hope we can get to 3 epochs before the time is up. All right, there we go. We are done. And what we have is not going to sound like anything, guys. So I'm just going to say that. But let's go through how you export the model. When you are done training the model, that's not the end of it. And this one also gave me quite some headache. Like, not a joke. Like, it wasn't a joke at all. Because Piper has a few bugs, and so that also has to be patched. So you see here, we are injecting something into something somewhere, but it works. So essentially, what you're going to need to do is to point Piper to your checkpoint. So your checkpoint is here. You see content drive. So you come to your drive, the mounted Google Drive. Um, let's scroll down. Yeah, mine is in this collab folder, and it's in the TTS folder. Aurora TTS is what I named it. Under that, you're just basically following this path. Okay, so yeah, don't let it confuse you. Basically, the path you have set here, yours may be different. So checkpoints. Aha. When you go to checkpoints, you may be expecting to find a checkpoint file sitting there nicely. You are not going to find it that way. It all gets stored in a Lightning Logs folder, this folder. And it's under that folder, you're going to have different versions. So if you've been running the training for a while, you're going to see sometimes version 0, version 1, version. Your latest checkpoint is always in the latest version. Okay, so if you had like version up to 10, your latest checkpoint will be in version 10. So you get the you have it. So Aha. See, inside that you have a checkpoint folder, and there it is. This is your checkpoint. So copy path to that checkpoint. When you need to export, you now paste that here in this export model code. Paste that here to replace, the default stuff we have there. And then basically, yeah, you have then, which is the path where you want the model to be stored. And then we click, we run the code. Patch applied. While this runs, it doesn't take actually that long to export the model. This is the fun part when you want to see how your model sounds like, right? And also ignore the warnings here, okay? Like it's like I said, you already know that metaphor I used, but this is what you're looking for. Info, main, exported model to this. So it has told you, it has exported your model to the path. You're good. You're ready. So now you're ready for inference. I want to tell you one thing about Piper. When you are inferencing, you need not just the model file, you need the model file and the config. I think it's the same for most models. But yeah, so it's very important. The config file gets created during training, okay? It contains information like the, the sample rate and the language and stuff. As you can see here, I already set a path for my config during the training. I set that path in my Google Drive environment, so it's saved there. Because it's very important, if you forget to save your config in the right directory, if you save only the model, after all the training, you realize you don't have a config, and you need to maybe run at least one checkpoint to just get a config back. So now, one more thing is your naming the config. So to inference from Piper, your config file must be named the same as your model, but with config, it's confused. Let me just say, okay, so let me just explain. So you can see here, the config file is named config.onx.json, okay? Now, when you are looking at this model here, you are looking at the config file name, then you must name this model also config.onx for it to be inferenceable. If you want to maybe name the config file in the same way that the model is named, then you are going to name it model.onx.json. Okay, so your config file should be in the same folder with the model file. It should have all the full name of the model, including the extension, the ONNX extension, plus .json. Okay, I've already stored that in my folder. I'm not going to kind of go through it because we are out of time. But essentially, okay. Okay, so here you go. You see, it's pointing to my model, which I exported. And inside that model folder, I have the config file there. Now we run the tests. Oops. I see the red, so that's not good. Okay. So you see the same thing I was talking to you about. The model, the JSON file, I thought I had placed it there. It was not there. So that's why you're seeing this there. So we have to place that config file that we have here. This one, we are going to move it to where the model is, and we are going to name it properly so that we get the right result. Let me do it. Sorry, we are a bit over time. We'll be done soon. collab. Uh, I have mine in the TTS folder. I have the config in this export. Did I put the config? Uh, Let me see this again. Okay, it's in the Aurora TTS folder. It's good we are going through this so that when you are in France and you know the issue, the simple small issues that can happen. So this is the config, right? That was it. So let's copy that or move it. Move. I'm going to move it to the same folder where I have my model. It is in this folder, so I'll move it there. And then I'm going to rename it, have the same name as my model file. So my model file is model.doc. So this one is also going to be model. So this. There we go. So let's try it. So yeah, now it's going to try to use that model and read audio output file. So there we go. Let's try this. I don't think you can hear it, but basically what I have is just muffled sound, but it shows you that it is trying to, number one, the first thing that helps you know that what you did change something. You see the length of it and you see what I can generate. Also like in speech, 29 seconds, kind of, what you want to get if you have this kind of, it shows you that you're on the, and then it's also giving you some stuff, not possible, but yeah, just movement and over. Yeah, essentially this is what you want to do. I hope I was able to explain things easy way, but when you do have to this and you have wish you can reach out community. Um, what I want to do is I want to create the Ghana TTS project kind of community on Black Channel, and I'm going to share it so that you can join that. And if you have any issues, you can like about it, like anything easier for to learn together. So yeah, we are going to have that support group for those people who want to just really get good at training Piper TTS models. Because it's really good path if you want to make a breakthrough TTS that can actually be also useful in our context. So I'll create that and we can keep it going from there. But I think that will be it for this session. I want to thank you all for your time. It's been a great session. I have enjoyed it. I hope it was also the same for you. Uh, See you next time. Have a great rest of the day. Out.